Today's video is called the halogen displacement reaction. This is an important reaction of halogens and it is part of the topic on C1. Now the halogens, as you probably know, are fluorine, chlorine, bromine, iodine, astatine, and they have a very particular reaction which we call the halogen displacement. Now, as the halogens are not the nicest of chemicals, and we're not going to use them as pure elements, we're going to use them as solutions. So we're going to use chlorine water, which you can see is colourless. We're going to use bromine water, which is orange. And we're going to use iodine water, which has a faint tinge to it. Now, in these reactions, we will react chlorine water with potassium bromide, potassium iodide solutions. We will react bromine water with potassium chloride, potassium iodide solutions, and we'll react iodine water with potassium chloride and potassium bromide. And we will look for evidence of a reaction occurring. So to start with, I'm going to use chlorine water with potassium bromide. So adding chlorine water, as you can see, we've got this yellow coloration, meaning that bromine has been released. Now, if I do the same with chlorine water and potassium iodide, you can see we get this dark orange-brown colour to show that iodine is released. Now, moving on, so there's a reaction in each of those. So chlorine has displaced the bromine and has displaced the iodine. Now I'm going to use I'm going to use bromine water. So for that, I'm going to react it first of all with chlorine. Now, if chlorine is produced, chlorine is a gas, so we would expect to see some bubbles. So any colouring there is due to the bromine water, but there are no bubbles, so there's obviously no reaction there. Now we're going to react with potassium iodide. So I add this to potassium iodide. As you can see, we've got this dark orange colour again. So iodine has been released, so a reaction has occurred there. And finally now, we're going to use iodine water. I'm going to react that with potassium chloride and with potassium bromide. So with potassium chloride, remember we're looking, if there's a reaction and chlorine being released, we'll see bubbles. Now, nothing at all, so there's no reaction there. Coming on to potassium bromide, there's no yellow coloration or orange coloration, so there's no reaction there. So iodine is very unreactive. So in terms of things, the most reactive is chlorine, because it's displacing both bromine and iodine. Then bromine, which displaces displaces iodine, but not chlorine. And finally, chlorine doesn't displace any of them. Now, what is happening in the reactions? So, let's have a look. So, with potassium bromide and chlorine, basically what we are getting a displacement. What that means is the chlorine takes the place of the bromine. So we get potassium chloride plus bromine, and that bromine is the brown colour. Now, with potassium iodide and chlorine, again, we get the displacement. So we will get potassium chloride again. And this time we'll get iodine, and that was by that dark brown coloration. Now, when we come round to potassium chloride and bromine, now, because bromine is less reactive than chlorine, there's no reaction. So the order of the reactivity, as we know, is chlorine is greater than bromine, which is greater than iodine. So the order of the halogen displacement reaction. Now, one last question for you. What could you use to displace potassium chloride?